Okay, for a question like this, I'm basically going to be showing you how to do it. So I'd really like for you to attempt maybe question A. Instead of this one, they're very similar, but if I'm going to be marking this question and I'm telling you how to do it, you just have to make sure you do another one, okay? So they want us to explain where each the numerator and the denominator comes from if we're trying to find the probability that the team selects the same order as the last performance. So if you have 9 dancers performing different roles in a dance routine, so you have from numbers 1 to 9, and you want them to perform the exact same way the next time, there's really only one way that that can happen. So that's where that 1 comes in, okay? There's only one way that you can have these dance performers perform 2 times in a row the exact same way. Now, the other number here comes from arranging your 9 dancers. So if you're arranging your 9 dancers, basically what's happening is that in the first slot here, you have 9 ways or 9 choices to pick from. There's 9 dancers to pick from. If I pick 1, then that means I have 8, 7, then 6, then 5, then 4, 3, 2, and then finally 1. Now, instead of writing this all out like this, you can just write that it comes from 9 factorial. If you try 9 factorial in your calculator, you will get 362,880. So that's basically that answer with a few complete sentences that explains how we got to that. Now, for question 2, what is the probability that the team puts the top hip-hop dancer? So the top hip-hop dancer, we don't know who that is. So they want us to put that in the 3rd position. So I'm just going to go ahead and put 9 slots again. 6, 7, 8, 9. Okay, in the 3rd position is right over here. And there's only one way that you can put the top hip-hop dancer in that 3rd position. And then if you put the top break dancer, there's only one way you can do that. That leaves 1, 2, 3, 4, 5, 6, 7 other slots for the other dancers. So those can be arranged however, but there's only one way that you can place the top hip hop in the 3rd position, and one way you could put the top break dancer in the 1st position. So then you would just go times, so 7 more to pick from, then 6, then 5 times 4, 3, 2, and 1, which basically means that you're doing 7 factorial. Okay, you've taken away 2 options, so you're basically doing 7 factorial. 7 factorial represents the number of ways to arrange the dancers as they mentioned at the top, okay? But we still need to find the total number of ways to arrange all the dancers. That's what your sample space would be. So if you're just arranging the dancers in any way, then it would be 9 factorial. So when you do the probability of having the top hip hop dancer in the 3rd and the top break dancer in the 1st position, you're finding the number of ways for that to happen divided by the sample space. And we already talked about why it's 7 factorial for the number of ways to arrange them. And then the total number of ways to arrange that would be 9 factorial. Now, if you want to do this the way I'm doing this right now, so I'm just going to expand the bottom to get to 7 factorial, because then that means I can divide these 2 numbers, okay, since they're the exact same. So normally when you expand factorials, you just stop at the lowest factorial. So in this case, I stopped at 7 factorial. And if I do that, then I have a 1 at the top, because 7 factorial divided by 7 factorial is 1, and 9 times 8 is 72. So as a decimal, as a fraction, it's 1 over 72. But as a decimal, it'll be 0. If I round this, approximately 0.014. Which means that if you multiply that by 100, you get approximately 1.4% probability of having that top hip-hop dancer in the 3rd position and top break dancer in the 1st position. In this knowledge section, I just went and fixed and wrote down that this is the communication question. Now for the knowledge question for question 3, you have a class building an academic team. There are 4 members on the task. There's a collector, an analyzer, grapher, and recorder. 10 people in class want to be on the team. So we pick a random team out of the 10. Okay, so if we're doing exactly 4 boys to volunteer, that means that we're picking 4 out of 4. Now you have to, oh, that shouldn't be a P, 4 out of 4. Now you have to realize if this is permutations or combinations. Since there are specific roles in this academic team, then that means that the order does matter. Because if I pick the first boy and I want him to be a collector, it should matter if he's a collector, an analyzing, grapher, or recorder. The role absolutely matters. So that's why we're going to do 4 pick 4. There's really only one way that you can put all boys. Okay, so if it's all boys, it's 4 pick 4. Now, if it's no boys, it'll be 0 boys out of the 4 that we're picking from. But this time, we need 4 people on the team, and there's only 6 people left. So this is the part that's a bit complicated. So you know that you want no boys, so 0 boys out of the 4 that you're picking from. But that means that you want to pick 4 boys from the 6 that are left over. Okay? Now, this is, they want to know the probability that the team is all boys. So there's only one way that can happen. Or, the word or means you're going to add. And this, by the way, is the number of ways to get all boys or no boys. Okay? I haven't done probability yet. I'm just doing number of ways to get boys or no boys. So I'm going to go ahead and calculate the number of ways to get that. So it's 1 plus, if you do 4 pick 0, I believe it's 1, but I'm not 100% sure. Just going to check it. Okay, so it is still 1, and 1 times 6 pick 4 is equal to 360. Okay, so if you evaluate that, it says, does this one say to evaluate or not? Let's just read the actual question here. Yeah, full solutions. Okay, so we're going to do 1 plus 360, which gives us 361. What we need to do is evaluate the probability, but to do the probability, we need the sample space. And the sample space here is picking 4 people out of 10. So it's picking 4 people out of 10. And remember, the order matters because these are specific rules. So if you do the math on that, you get 5,040. So to do the probability, all you have to do is do the number of ways that you want 0 boys or all boys. Divide that by your sample space. And that will give you this answer here, which you can then turn into a decimal or a percentage. Okay. Now, evaluate, or what is the probability that student 1 and student 2 are on your team? Well, again, there's only one way that that can happen. So if you're getting student 1 and student 2 are on your team, that means you already picked 2 members of the team. So that means there's only 2 people left. So again, there's only one way to pick student 1. There's only one way to pick student 2. And then after that, there are only 2 students left to pick from, a total of 8 students that are left over. Okay, so in this case, you would do 1 times 1 times 8p2. And we know 1 times 1 is just 1. So if you do 8 pick 2, it gives you 56. Okay, so that's the number of ways that you can have student 1 and student 2 in the team. Now, if you need to do the probability, remember that it's n at a divided by n at s. There's 56 ways to have student 1 and student 2 on the team. And then finally here, we have 5,040, which is your sample space. Now, for question C, with 2 teacher coaches, the team of 4 takes a picture. So now there's 6 people taking a picture, okay? And they want to know what is the probability that the teachers are together in the picture. So we can have the teachers sitting together in 1, 2, 3, 4, five ways, but if you flip the teachers, it doesn't matter who's first or second. So there's actually 10 ways that the teachers can sit together. But that leaves extra spots for the other students. So if the two teachers are sitting over here, that means teacher 1 can be over here and teacher 2 can be over here, or vice versa. So there's 2 ways there. And then we have 4 members on the team. So there's a couple different ways that we can arrange these 4 different students because there's no specific order. So there's 4 ways or choices for the first member of the team, then 3, then 2, and then finally there's only 1 left over. So we know that this answer here is 12 times 2 is 24 ways for the students to sit together. So what you can do is there's 10 ways for the teachers to sit together, and there's 24 ways for the students to sit together. And then if you noticed, I said the word and, I said it pretty quickly there, but 10 times 24 is 240. So there's 240 ways. Now, to do the probability, again, remember that the probability is the number of ways of what you're looking for, and then divided by the sample space. Now, the sample space this time would be 6 factorial, because you have 6 ways of placing the first person, 5, then 4, then 3 times 2 times 1. So the sample space has no restrictions. So basically, we're doing 240 divided by 6 factorial, and then you'll get your answer there if you give that a try. There's more than one way of doing this. I don't know if the video or the solutions in the actual course showed it the other way, but when you're trying to arrange 2 people together, 1, 2, 3, 4, 5, 6. Okay, so if there are 6 people and you're arranging 2 together, doesn't matter where they are, so let's put them right here. There's 2 factorial ways that those people can be sitting together, okay? But then what you do is there's 1, 2, you count this as 1, 3, I'll just put that like that, 1, 2, 3, 4, 5 factorial ways of arranging everyone else. So what you could do is do 5 factorial times 2 factorial, which it should give you the same answer. Okay, so 5 factorial times 2 factorial. So if you try that, if it doesn't work, then I'll have to see what I'm doing wrong here. But that does work, because since 5 factorial is equal to 120, and 2 factorial is just 2, which means 240 ways. That's only for your number of ways of which you're looking for. That's not your sample space. So I find the top method makes a little bit more sense to me, but it depends how you want to calculate it. But if you want to understand both, then you're set to go. Let me know if you need some more help.